This is geotrig, lesson 2, day 2 of our notes. And so the first thing I want to do here is we should have covered how that whole idea that it didn't matter what kind of triangle you had. I showed you all 3 triangles still use the same formula, and that formula was 1/2 base times height. We finished that, right?
Yes.
Okay. So, the first one's a triangle, the second one's a rectangle, and the third one is a circle. 2 out of the 3 here should be more review, if anything. Well, okay. What is the area of the triangle? Notice that the red outline is added stuff. Now, I could be that guy, and I could say, show me the work with right triangles. And then most of us probably wouldn't want to do that. So, we already showed that yesterday that it works. So what it's highlighting here is the height. What's the height? 6. And the base is 10. Because we're not talking about the red attachment there. We are just talking about the triangle that is in black. And so, area formula. One half base times height. Guys, if I use this formula 100 times, you will see me write it down 100 times. It only makes sense that if I'm going to use a formula, I'm going to write it down. I've been doing this for 11 years and I still write it down, even on my answer keys, even when I'm doing this for my own enjoyment. I'm less likely to make a mistake if I have the map in front of me. If we're all going to take a trip to Wisconsin Dells, I don't know how many people could get there on their own merit. They're probably going to take out Google Maps and tell me, get to Wisconsin Dells. Right? And you're going to follow that map. You're not going to put it on the computer or on your phone and then ignore it and think, I'm just going to get there. Write down the formula, fill it in. 1/2 is 1/2. What's B? What's base again?
10.
What's your height?
6.
6. What's 6 times 10? Times 1/2. The units on this thing? And it's feet squared because we're talking about area. Guys, could we have also done 1/2 times 10? It's 5, and 5 times 6 is
30.
I do believe that's the associative property. I can use them in any order I would like. 2 is a rectangle. What's the area of that one? Length times width. Base times height. Doesn't matter. What's the width?
16.
What's the height? Or width, or width, or height. Wow, length. Doesn't matter. Right? If I start with 10, then I have to use 16. If I use 16, then now it's 10.
Correct.
What's 10 times 16? 160 feet squared. Those first 2, I'm assuming, are pretty good. In 3, the question you might ask is, what is 18? It seems to be conveniently in blue on one side. So your first inclination might be, that is the radius, yes?
Correct.
But the whole entire line is in blue. The color of the number 18 is in blue. My inclination on this would be, that's the diameter. So R actually equals what? Bless you. R does not equal 18. R equals 9. And what's the formula for a circle? Pi R squared equals pi times 9 squared, or 81 pi inches squared. Notice I did not use 254 and change. 254 point la-di-da-di-da would be the decimal approximation for this, wouldn't it? It's very important. Don't approximate until you absolutely have to. Notice that we didn't use a calculator yet. If I asked you for the approximation of that last one, would you have to use a calculator? More than likely, right? So it's easier not to. There's a time and place, exact answers, you leave it with pi. Pi is an irrational number. Just like square root of 2's and square root of 3's, square root of 5's, so forth. Questions? This one. This one's a fun one. It says find the area of this figure. How are we going to do this? What kind of figure is that?
Trapezoid.
It's a trapezoid. Do we have, did I give you guys yet the formula for an area of a trapezoid?
Yeah.
I don't think I did.
What are you talking
There is one though. There actually is a formula for the area of a trapezoid. But I'm not teaching you it. Right now. Hey, look at that. They told us the perimeter. Does that make sense? 3 plus 5 plus 6 plus 4 equals 18 feet. Does that make sense?
Yeah.
Okay. But how am I going to use what I already know to find the area of that object? Jake?
You could cut into a rectangle and a triangle.
Yeah, cut it into a rectangle and a triangle, guys. Couldn't I just cut it right there? Wouldn't that form a right angle straight down?
Yes, it would.
And now you have a triangle and a rectangle. Could you tell me the dimensions of the rectangle? They just happen to be right on that rectangle. What are they? 3 and a 4. So, doesn't that mean that this is also 3 down here? And this is 4 over there?
Yes.
Because definition of rectangles. Opposite sides are congruent in size. Hey, that's really cool because now it gives us the height of the triangle. How do I know this base though?
It's 3.
Why is it 3?
Half a 6.
Not half of 6. I wouldn't go that far.
Well,
I wouldn't say half of 6. It's 6 minus 3. It happens to be also half of 6. But guys, the only reason we know that is because this was 3. And when I drop straight down, it becomes 3 as well. Then I take it from 6. But if that would have been a 2, the base is 2 over here, that means the triangle had a base of 4. Right? Because 6 minus 4. 6 minus 2 is 4. So it works out that way. So wait a minute. So if I find the area of this guy and add it to the area of this guy, I have the total area. And you're saying this is 4 times 3, so length times width, 4 times 3, which is 12. This guy over here has a 4 height, 3 base. Area equals 1/2 base times height, if I can just put that on there. Which means this would be 1/2 3 times 4. I think it'd be easier to do half of 4 than it is half of 3. Half of 4 is, so 2 times 3, so it's 18. What do we in here? Feet? Feet squared. Now someone's going to come up with this huge conjecture. They're going to come up with this idea that, wait a minute, the perimeter was 18 and the area is 18. That means they must always be the same. Is that true? No. So I want you guys to take page 20. There's an example called example 2.3. This is the shape. And I want you guys to find the area. So if you don't have your book, just copy it off the board here. So these problems, guys, the problem above, problem here, what do you see? What are you going to do? Two shapes. So to find the area of the whole thing, you're just going to split them up, like your summer romances, right? So I have this rectangle, and I have this half circle we call a semicircle, yeah?
Yes. Correct.
Hey, do I know the dimensions of that rectangle?
Yes.
That's a 2 and a 3. And that's length times width. I know that. That's 2 times 3, 6. That was super easy. Then if I add it to that semicircle, what's the area of a circle again? That's pi r squared. But do I want the whole thing? So I want how much of it? Half. So can I just divide it by 2? Is that okay? What happens to be the radius of that semicircle? Yeah, the radius is 1. So that's pi times 1 squared all over 2. What's 1 squared? And times that by pi. So isn't that just pi over 2? So it'd be 6 plus pi over 2. And I don't know what the units are. Is it feet again? Meters? Inches? I don't know. It's meters? So it'd be meters squared, according to whatever the diagram is. Now wait a minute, Mr. Konchak, why didn't you take that pi, divide it by 2, that's 3.14, divided by 2, so about 1.57-ish? Add it to 6, so that's 7.15, or whatever, 57? It's because I don't want it an approximation. I want the exact answer. 6 plus pi over 2. That's your answer. Didn't need a calculator. Works out beautifully. If I gave you guys a calculator, could you guys work it out?
Yes.
I'd hope so. Notice where pi is also. Would it be wrong if I let pi over 2 plus 6? No. You can add numbers in any order. But pi is irrational. Square roots are also irrational. Where did square roots always go? Where did I always go? Right? Imaginary numbers? They always went at the back.
Yeah.
So pi would also be one of those times where you put it at the back where it's needed.
But you wouldn't mark it wrong if we had pi in front of
As in pi over 2 plus 6? No.
Okay, but you want it.
It's kind of like standardizing it, right?
Yeah.
So a plus bi form,
Okay.
standard form, things like that. We good?
Yep. Yeah.
Now, another one. Go back a page to page 19. Draw this. So you should have this object that looks like an ice cream cone that was not well constructed. We got 2 semicircles and 2 triangles. You guys agree with that?
Yes.
Give you guys some time to copy. Now, let's go back to what we did on the last 2 examples. We took it apart. I didn't try doing everything at once in my head. So, I break it up. I have a half circle. I have another half circle. I have a triangle. And I have a triangle. You notice that, can you guys visualize which piece I'm talking about by the shape and the direction it's in?
Yes.
They don't have to be in that order. They don't have to be all set up this way. I could change them around. I could uniform them a little bit more. But all I'm trying to do is see that, hey, this one was here. This one that's on the right, far right is over here. So I can start labeling them as well. So I have a radius of 5. What do you think that 6 stands for in that circle? Probably the diameter, which means if I had to, the radius would be 3. If I put an extra 3 in there. A little hard for you guys to see that, I think. The triangles. Ooh, this one I have 2 dimensions, right? A base and a... Ooh, we like that. And this one, I have a 6, an 8, and a 10. Is this enough information, you think, to get our answer?
Probably yes.
I know I've got to find areas, so therefore I'm going to use formulas. So I'm going to, I said do this every time, guys.
No, right.
Write the formulas down.
Yeah.
Pi r squared over 2. Next one is a pi r squared over 2. 1/2 base times height. 1/2 base times height. Now all I have to do is take those and add them all up. This is not. Break it up into smaller pieces. It's more manageable. And you start to see that a lot of things in life are made up of shapes that you guys know.
Like stop signs.
Right.
Hey, that's
That's a good example.
Okay. R in the first one is, bless you, over 2. That'd be 25 pi over 2. Now, someone asked last time, can that be 12.5 pi? Because 25 divided by 2 is 12.5, yeah?
I guess.
That's fine. But here's the thing. That means you got decimals times pi. Pi is an irrational number. It's a decimal too. If you're going to leave it as 12.5 pi, then you might as well just take your calculator and give me the value. Leave it as an improper fraction, 25 pi over 2. Next one. Radius is
Radii.
3. 3 squared is 9 pi over 2. 1/2. What's the base? 8. Height? 6. 8 times 6? 48 divided by 2? 24. Now, would it be maybe easier to go 1/2 times 8? It's 4. 4 times 6? 24. It's all going to work. Next one, 1/2. What's your base? 8. Okay, then what would the height be? 6. What if I call my base 6? Then what's the height? 8. Notice that it's a right triangle. I could lay it down on 2 different bases. Could I also use 10 as my base?
Yes.
Yes. But then you would have to do a little bit more searching to find the height, wouldn't you?
Yes.
But are you given that information?
No.
So then don't use it. But you could do it. There's ways to make it happen. So, like I say, wait, that's 24 again, isn't it? Notice that I got pi's right now in front, numbers in the back. So we're going to flip it around. 24 plus 24, they're like terms. What do you get? So 48. What's 25 pi plus 9 pi? Notice they got common denominators. I'm not worrying about that. We're going to be over 2. That's fine. What's 25 plus 9? 34 pi. Hey, I can reduce that. What is it? 48 pi. Oh, sorry, not 48 pi. 48 plus 17 pi. Units squared. I don't know what the units are, but if it's inches or meters, so it'd be inches squared. And I don't need, guys, I don't need a calculator. I didn't need a calculator for this problem. Now, if I want an exact answer, then yes, take a calculator out. Okay, moving on from area, let's talk about volume. Volume works in the third dimension. Us, we're in third dimension, aka 3D. Third dimension, examples of something that has volume. Your water bottle has a volume, usually about 1 liter, right? 1,000 milliliters. Volume is something that takes up space. Your book has volume. Okay? And so now we have a couple different shapes here. These are the more common shapes. Later on, we're going to go into a little bit more different ones here. More different. That's good, right? Rectangular solid, cube. Both of those. What would be an example of how to find the volume of that? How do you find the volume of a rectangular solid?
Length,
No, not 1/3 anything.
length times width times height.
Length times width times height. Length times width times height. That would be for both a rectangular solid and a cube, because a cube is a rectangular solid. The difference between a rectangular solid and a cube is that the cube has all
Equal size.
equal sides. So instead of length times width times height, you might have L times L times L. Usually when it's a cube, they use S, so it'd be S times S times S. Cylinder. That happens to be a circular cylinder. Can of soda. Okay. How do I find the volume of that? Radius has to do something definitely with the radius.
Squared.
How about pi r squared h?
Oh.
The cylinder. Now, there's a reason I'm doing this. I'm talking about these three objects. It's because they highlight this idea of what volume is really nicely. What do they both have? Or all three of them have? And their formulas.
V.
What do you mean B? They have a height.
H.
H, right? They have height. So what if I separated my height from the rest of the stuff? What is length times width? Area of what? Length times width is the area of the
Rectangle and cube.
is the base. What's pi r squared of that cylinder?
The base of the cylinder.
It's the base of the cylinder. It's sitting on a circle. That is a base. And so volume would equal AOB times height. The area of base times height is how you find the volume of almost any object. Guys, when we talk about area, area has absolutely no height to it. When we draw these figures on the board or lines, they take up no space. We have an area, that's a length times a width on a board. But it's as soon as I start to say stack layers of paper on top of each other, your item starts to get taller, which starts to have a volume. Like everybody right now can look at one of my whiteboards in the front of the room. To you guys, it's just a flat piece of, I don't even know what whiteboards are made out of, some kind of board, right? It's made out of whiteboard. Yes. But if you were to walk in the room from the side, you would actually see that the whiteboard actually has a thickness to it. It's only about maybe a ½ inch. But that ½ inch now gives it a volume. So when you look at some object straight on, like that object there, right here, it's two-dimensional. But what if I said I had a whole bunch of those stacked up and it came out of that board by, say, 5 inches? I would have this weird shaped object that looks like an ice cream cone, 5 inches tall in that shape. Now it has a volume. You would take that area, 48 plus 17 pi, and times it by 5. Volume. Up next are another 3 objects. One's a sphere and the other 2 are cone and pyramid. A sphere, guys, the volume is actually 4/3 pi r cubed. There's a problem in your book that's actually going to make you kind of build it. Because here's a really cool thing. I know they don't do this, and actually the tennis player just left. When you guys go buy tennis balls, they come in a pack usually of 3, right?
Yes.
And they're in that really cool can that is on, kind of makes a nice cool sound. They're vacuum packed. But what happens if you could buy one for only 1 ball? It is cool. Now, the cool thing about this sphere and its volume is that the volume of the ball would actually be 2/3 of the volume of the smallest can that it would fit into. And there's a reason. You guys will go through the makeup of all of that. You got to think about your radius and how it's used and stuff. But 2/3 of the can can be are still there, so actually 1/3 of it's gone, leaving you with enough to make the ball. Cones, on the other hand, look at this one. What if I made a can to fit the cone?
Boom.
You guys know that's a circle on the bottom, right?
Yep.
So isn't a cylinder pi r squared times h? That would be the whole thing, right?
Yeah.
Well, guess what? If I took away 2/3 of it, 1/3 of the total volume of the can would represent a cone. It's volume.
That blew my mind.
So you can start out with this circular jar, right? Circular cylinder. And I could take and cut away 2/3 of it, and I would be able to form a cone. Pyramids, guys, are the same thing, but a pyramid could be a rectangular base. It could be a circular base, if you we call those cones. It could be a triangular base. So when I talk about a pyramid, volume is 1/3 AOB times height. And that's for the volume of a cone. I think it's a cone and pyramid. Volume of a cone / pyramid is 1/3 the area of the base times height. Okay, day 2 of lesson 2, page 24. This is the first day of homework, but in the video sequence, this is day 2. 1, 2, 3, 16, 19, 24. Guys, some of them are the complementary angles. One of them asks you, what is a scalene triangle? And then a couple other ones have you work a little bit. Have a great day.